Hello and welcome back to the Retro Remakes project in Unity. In this part we will take a closer look at the extras feature of the roller maze game. Like shown before, you can see the extras here in this green window, and when the game is running, with using your right mouse button you can cycle through all the extras and you can see how many of them you have. For example, here we have bought a hammer before, and when we are close to an open tile where no floor exists, we can just use the left mouse button and then the hole will be filled with a floor tile. Another example would be the spikes extra, this one here. This enables you to slide over ice and have a bit more control over your ball. Right now it's a bit hard to control on the ice, but let's just buy that extra real quick. We don't have that extra here in the level, but we can just add it real quick. Go to the floor layer, add the extra here and also the price. And then of course we need money for that, so on the items layer we will add a coin. So let's go on. Now we have the money to buy, and now we have the extra. You can see it here, we have one spiked ball, and now when we are clicking the left mouse button we have the green spikes on our ball, and now the ball is very well to control on the ice. So let's stop that and let's take a look in the code of that. Here we are in the player controller again, and I want to show you the old solution with which I started, because then you might better understand why the current solution is in place. You can see I have defined here an enum extra type to distinguish between the several extras you can have in the game. And then I had those two variables, selected extra, that is what you can see in the UI by clicking the right mouse button and cycling through the extras. The one that is shown in the UI is a selected extra, and when you click your left mouse button, then the activated extra will get set. And in an early version, these were enum variables, extra type, and they were just containing one of these values here. Now let's do a quick time travel on this class player controller and take a look at an earlier version of that class. Let's make this a bit bigger. This is the new version, the current version, and this here is an old version. You can see I had named the enum extra, not extra type, and these were the standard values of the extra at the start of the game. Now these enums were used quite often in this class, for example when pressing the right and left mouse button. Let's go to the update method and check mouse input. Here you can see cycle extra and activate extra are already there, like in the current version. And here you can see cycle extra was just cycling the value for the selected extra value by going through all the enum values and so on. And activate extra was this very long method with all these if, else if statements. So depending on the selected extra, we had a different behavior. For example, when we have selected the hammer extra, this is here called pickaxe internally, then this behavior was executed. And if not, if our selected extra was the spikes extra, then this code here was executed. Here we also have set a timer, how long this extra will be active, and so on. And in the timer method, here we have decreased the timer over time, and if the timer was below 0, then we have deactivated the extra. And this is here, deactivate extra, and here you can see there were also a few checks what extra was activated. If activated extra is spikes or armored ball, then we have this behavior here. And as you can already see, these enums are scattered throughout the class here. And if we want to add a new extra, these are all the extras we have, then we need to be really careful to check all the places here in the player controller class to see if these are relevant changes we need to make. For example, if we have a new extra that sets the texture of a ball, then we have to add it here to return to the normal texture. And then we have a new if activated extra is extra spikes or armored ball or our new extra. And this is prone to error because you might forget one of those places. And also you need to add another if-else case here in this activate extra and put your behavior for the new extra in here. And after a while that might get really tangled up and you lose a bit of the overview of the class. And also the class will get bigger and bigger, and it's already a really huge class. And so I decided to extract all this extra functionality in separate classes. And you might have heard about the keywords separation of concerns or the solid principles of software engineering. You can Google them and read a bit about them if you're interested. But for now, let's close this up and worry about how we can extract this logic of the extras in another class and keep it out of the player controller. It would be really great if we don't have to bother the player controller with the extras, and when we're adding a new extra, that we don't need to change the player controller. I mentioned the solid principles of software engineering, and the O in solid stands for open for extension but closed for modification. And that means you can add an extra and the player controller can work with that extra, but you don't need to change the player controller itself. So a new extra would be more like a plugin that you can just create and then the player controller can work with it. And that's what all these extra classes in this extras folder do. Using that approach has led to the player controller having only very limited and very defined interaction with the extras. Let's take a look. The first change is those two variables are no longer an enum type, but are of the type extra. We will take a look at that in a minute. Then in the update loop, you can see here we have that one line, activated extra update. So any extra that is not executed immediately, but is running for a while, for example, like the spikes extra that gets the new code, the new spikes, and for 40 seconds you can roll over ice without any problem. Then the behavior of that extra is controlled by the update. And note here, we don't have any if-else statement in here, so the player controller doesn't really care what type of extra that is. It is just a generic extra, like I mentioned, like a plugin. And the extra has an update method and that gets called. Also, when the extra gets activated, you can see here, all these if-else, if-else, if statements are removed and we have only one line left. We check if there is an extra that was selected. Then we check if the selected extra can be activated. For example, we have to buy one before we can use one. And then the player controller just calls activate on that extra. So let's take a look at this ominous extra class. You can find it here in the extras folder. Let's double click. And as you can see, here's a short description, and it is an abstract class called extra. And an abstract class is almost the same as a normal class, with the exception that you can't create objects or instances from an abstract class. So you can't just have an extra, but you have to specify which extra you want to use. And therefore you need to subclass this extra class. For example, the spikes extra. You can see the class spikes extra has derived from the extra class that is here. And this extra class, this abstract class, is a base class for all the extras that we are using in the game. And this base class has several methods, like can be activated. We have seen this before. It checks if our amount is greater than 1. And we have the activate method, and we have the update method, the deactivate method, and so on. and these methods already contain a standard behavior for all extras. So for all extras, the check can be activated is done in the same way. We will check if the amount we have from that extra is greater than 0 and if the player controller is not disabled. So we don't want to activate any extra by accident when we're looking at the map, for example. And the standard behavior when we are activating an extra is we check if it is a consumable extra. You can see here the variable is consumable is set to true in a standard extra. So usually an extra is consumable. That means you have to buy an extra to use it, and when you're using it, the amount gets decreased. Then we check if it is an extra that has a certain duration that lasts for an amount of seconds. Then in the player controller, we set the activated extra variable to this extra we are in here and set the remaining activated extra time to the duration. That means for the spikes extra, for example, we set the amount to 40 seconds, and then in the update method of the extra, this time here gets reduced, and when it falls below or equal to 0, then it is deactivated, and that means in the player controller the activated extra is set to null. And our spikes extra has exactly that behavior because we are deriving from the extra base class. And what makes that approach so great is that the player controller is just seeing the spikes extra as a normal extra and doesn't know that it's a spikes extra or that it's a parachute extra or pickaxe extra. The variables that the player controller has are just from the type extra from the base class, and the player controller knows the base class has methods can be activated, activate, update, and so on, and it's just calling those methods. That means you don't have to do these if-then-else cases in your code in the player controller. If my extra is a spikes extra or is a pickaxe extra, you can just say my current extra dot activate, and then the extra gets activated. So, but if every extra derives from the base extra class and then has the same behavior, then you might wonder, how do I get different behavior for the different extras? And that is another great advantage of the abstract classes, like we have here with the base class extra. Because an abstract class can declare its methods as virtual. You can see the keyword virtual here, and we have done so for the can be activated, activate, and so on. These are virtual methods. And what that means, in your child class that derives from the base class, you can define these methods again and use the override keyword. And what happens now when the extra in the player controller is spikes extra, but the player controller just calls extra.activate, then C# knows, oh, we are really a spikes extra, and the activate method is defined in the base class, yes, but we have overridden it here. So I will execute the code that is defined here in the spikes extra class and not in the base class. And by that you can more or less manipulate the base class, if you want to say so, and achieve different behavior for your child classes. For our spikes extra, for example, we want to have all the behavior that the base class has, and we can achieve that by using base.activate. What that does is calls activate on the base class, which is the extra class. So base activate just calls activate on the base class. So all this code gets executed. And then we continue with an addition to that. So the spikes extra has to do something that the base extra class has not done. And that is setting a new texture. We're calling the player controller set spikes ball texture, and then the texture of the ball gets changed. So that is an additional behavior that only the spikes extra does, And we do it by overriding the standard activate method from the base class and adding our custom code here. You can also see here in the spikes extra constructor with which we create such an extra object that we set the duration in seconds to 40. And you don't see that duration in seconds variable here in the spikes extra class because we have inherited it from the extra class. Let's go here. Here you can see duration in seconds. For any extra, it's usually 0 seconds. It gets activated at once and is done. But for the spikes extra, we set the duration to 40. And then if you remember, when the extra gets activated, in the update loop of the player controller, update gets called every frame. And for the spikes extra, we don't have an update method here because we don't need any special behavior for it. We just want to execute the standard behavior. And in that case, when we have the spikes extra and update gets called on it, and it's not found as an overridden method here, then the method of the base class gets called. And that's the method here, update. Remaining activation extra time is 40 at the beginning, and then it gets decreased and so on. So by deriving those classes, those extras from the base class, we can here adjust certain values that define a behavior that deviates from the base class. And we only need to define what really deviates. We don't need to write the update method here again. Let's take a look at another example. The pickaxe extra, like I said, it's the hammer extra where you can fill holes in the floor. You can see here we have two methods that we override. The can be activated check is a bit longer, and the activate has also a behavior that extends the behavior of the base class. So when the player has selected the pickaxe or the hammer extra, then the can be activated method call gets directed to this method here, because we have overridden the base class behavior. In here we call the can be activated method of the base class because we want to keep this check here. We don't want to repeat that check in our new class. So we get the value out of this can be activated of the base class. But additionally, we check if we are in a position on the map where we can activate that extra. And for that, we ask the player controller to find us an empty floor tile in the proximity. So around us, there needs to be an empty floor tile where we can see the void. And if such a position was found, if it's not the no tile found vector, I will come to that in a minute, then this extra can be activated. So when you have the hammer selected as an extra and you're rolling around the floor and have no tile in your vicinity, then you can click your left mouse button and the extra won't get activated and you don't waste your hammer because it would have no effect there. And on activation, we also try to find an empty floor tile in our proximity, and then the floor map set tile will get called, and on that tile position where we have found an empty tile, our floor will get set. So basically the empty tile gets replaced with a floor tile. And here you can see my remark, instead of null check, because vector 3 int can't be null, we have this find empty floor tile position in proximity. And what that does, it looks around our current tile position and tries to find a null value in the floor map. So floor map get tile, when there is null as a result, then there is no tile present, and that means the floor has no tile and we can see the void. That is an empty floor tile position. And if we don't have such a tile around us, then we go to this case and return the no tile found vector. Usually if you don't want to return any value, then you use return null, but we can't return null here because we want to return a vector 3 int, and that is a value object and can't return null values. The vector 3 int can't be null. So I defined a constant for that. Let's go to the definition by holding Control and click on it. And here you can see it's defined above here. Our no tile found vector is a new vector 3 int with the coordinates -999, -999. And if you go back to our pickaxe extra class, you can see here we try to find the floor tile, and then we compare the tile position with a new vector 3 int -999 -999, and that is hard to read because you might not know what that means. So it is better to use this defined constant player controller no tile found vector. Then it is immediately clear what this value here means. So this is just here as a comparison. Usually you would also put here no tile found vector. Let's take a look at one more extra, the eye extra. And the eye extra is used to show the map. When you're collecting one eye that is lying around on the map, then you can activate the extra and you will see a map of the level. And the more eyes you collect, the better the map will be. The more detail it will present to you. And that means an eye extra is not a consumable because you want to collect eyes and then get a better map. But when you're using the eye extra, you don't want to lose precision on the further inquiries on the map. So we have set the isConsumable variable to false here for the eye extra. And when we activate that extra, you can see we have overridden the activate here, but we're calling the activate of the base class here. And here we check if isConsumable, then the amount gets decreased. But because we have set isConsumable to false for this extra, then we will keep the amount. And on activation, then our UI manager shows the map and the amount of collected eyes is put into that, and this will generate a map that has greater precision the higher the amount of collected eyes is. One more thing that might look a bit strange maybe, here in the constructor we have this colon and base behind that, and that just means that when you're creating an eye extra with new eye extra, then the constructor of the base class is also called. The term for that is constructor chaining, because you're chaining two constructors behind each other. First, the base constructor is called, and then this constructor is executed. And what the base constructor does, you can see in the base class, here it is. This is the constructor for the base class. These variables are set. For example, the amount is set to 0 because when this extra is created, we haven't bought any of that. We have just the object that holds the information. And then the eye extra additionally sets isConsumable to false. And you might wonder, yeah, but where do we construct these extras? Where do we call this constructor? And that is done here in the player controller. In the start method, you can see it here. The start method has a lot of initialization to do. And here we set our extras that are available in the game to a new extras collection and give ourselves, the player controller, into that extras collection. And what that extras collection is, it's just a list of extra objects. And when we're calling that new extras collection, then the list is created and we add all the extras we have in the game by using add, that is the method of the list class. And here we create a new pickaxe extra, a new spikes extra, and so on. And then in the game, when we are clicking the right mouse button, we cycle through all these elements here. So basically what that means here, we create a collection of extras but with an amount of 0, and when we buy such an extra, then the amount gets increased for that extra. And what these constructors also do, you can see it here in the constructor, we have to give it the player controller, and we have to give it an array of tiles where we can buy that extra. And you can see it here, the pickaxe extra can be bought on the buy pickaxe tile. And for example, the eye extra can be bought on the eye left tile or the eye right tile. The eye is an extra that stretches over two tiles with a left part and a right part. And that is used in the player controller when we are rolling over an extra. We have a buy extra from tile method here. Here it is, buy extra from tile position. When we're on a tile position and want to buy an extra from the tile position, first we determine what extra that is that corresponds to a certain tile, and then we call the buy method on that extra, and that just increases the amount of the extra. You can see it here. It's in the base class defined amount gets increased by 1. And this find extra for tile base, where we insert the tile at the tile position, and the tile is on the floor map, is that method here. And that goes through all of our extras in our extras collection here on the player controller, and it finds that extra where this tile that we inserted here is equal to one tile that is in the tiles to buy array. That means, for example, when we're on the iLeft tile, then iLeft is part of the array of the tiles to buy for the iExtra. And then this find extra for tile base goes through all these entries here and is looking at this array and tries to find the iLeft tile. And when it finds it, for example here, the iLeft, then it returns the iExtra. And this is what this whole expression does. We're going through each extra, and for each extra we take a look in the tiles to buy array and compare each tile in that array, and if one tile of them matches the tile base we have inserted here, then this extra is returned. So that is everything you need to know about the extras and how they are implemented and where they came from the simple enum and the if then else checks in the player controller. Now we have a much more flexible system. We don't need to change the player controller at all. When we want to add another extra, we just derive from the base class, for example, as I have shown here, and then we override certain methods where we want to have different behavior or want to specify what that extra does, and then we have to add it to our extras collection here, so the player controller knows what extra to take when we roll over a certain tile and want to buy that extra. I know it sounds a bit complicated or a bit complex if you haven't heard about abstract classes and derived classes and so on, but don't worry about it. You can always ask questions in the comments or on the Discord channel, and you can also Google abstract classes, and there are many examples that will clarify the situation. And I think it's very useful to have this example here, because then you can see it not as a concept you have to grasp in an abstract way, but you have a concrete example how it is used and what it's good for. If you don't get the grasp immediately, don't worry, you can always revisit the code later, and you should do so because it's a very powerful concept. I hope that information was useful for you and you can now understand how this whole extra system works. I hope to see you in the next video. Until then, happy creating and take care.